Good afternoon, everyone. Welcome to the class ECE341, the probability and stochastic process. Today we will have a review for the second midterm exam. All the things will be similar with the first midterm exam. You should already know that, right? Okay, now let's go over for the reviews. Okay, ECE341 is a 10th week Friday's class. It's a review for midterm exam 2. Okay, the time of the exam, they'll be on the 11th week Monday's class from 3 to 4 and plus 30 minutes. That's similar with the first midterm exam, right? There will be 3 to 4:30 p.m. Alright, and here we have the spring break, so this 11th week will be, now is 10th week, right? Next week, so that will be, I think it's March 25, 27, 29, right? 22 is the Monday for the spring break. 22 plus 7, 29, yeah. March 29. Alright, this is the time. And we are the problems and where to you need to submit, right? In the Blackboard, you go to the assignment and test. I have a folder, right? The same with the homeworks. Then in that folder you can see you will have a midterm exam 2. Midterm exam 2. You can download the problem from there, and when you're done, you will upload your problem, upload your papers just from here. Alright. What else do we have? Okay, I will give you an announcement and maybe some more details. Okay. And okay, one more thing. For the exam, totally there will be 4 problems. Alright. Okay, this is in general. And of course, as I mentioned the last time, you need to prepare your formula sheet before you start the exam. Actually, during the exam, you can use anything, the textbook, the notes, even search online, but I suggest you do a formula sheet before you start. That will save you time to find the necessary materials. And if you didn't have these, you do not have these kind of things, maybe you need to pay a lot of time to search your materials. That will cost a lot of time, and our time is limited for the exam. Alright. Okay, and for the exam, the coverage, we will cover chapter now is for the random variables, right? Chapter 3, 4, and 5. We have 3 chapters. The sections. Chapter 3, we will have, I think it's 1 to 8. Yeah, 1 to 8, sections 1 to 8. For chapter 4 is 1 to 6, and chapter 5 we have 1 to 10. Yeah, I can have a look. 341. Okay. I think usually I go to the 10th page. Oh, not 10. Not enough. We need more pages. Okay. This is contents. Chapter 3. Chapter 3 totally 9 sections. We only need 1 to 8. Yeah, 1 to 8. For this section, we have some part. We have them and before the first midterm exam, but this time we still contain the first two or one or two. For section 1, 2, 3, we have these before the first midterm exam, and they are included in the first midterm exam. But now we still need this part. So if we say for the weeks, we will consider week 5 until so far is week 10. All right. So week 5 we have it again. This is again. We need them again. Yeah, let me write here. So for the weeks, week 5 to week 10, and we need week 5 again. All right, this is covered. And then how to review. Actually, for the textbook to review, you'd better use the homeworks as a guide for review. Alright, so you use the homeworks. You go over the homework problems, you read the homework problems, then every homework problems it was related with something. For example, you have if you have a problem like a CDF is given and ask you for some probabilities, then you should know what is a CDF, right? And how to calculate the probability. So you need these two things. Another thing is like you have a PDF, then you're asking for the variance of the random variable. Okay, so you need 3 things. What is a PDF? What is a variance? And then how to calculate the variance based on the PDF. So you need to know these 3 things, right? So you go over all the homework problems, and each problem gave you some concept, some method, some formula. You use that as a guide to do the review. All right, yeah. And of course, you if you have enough time, or maybe you already did that, you already read the textbook overall, that would be great. So you can also do that, yeah. Okay, but I suggest you try to review by this way. All right. Okay, then we go back here. We have chapter 3 from 1 to 8, and chapter 4 is also 1 to 6. I don't have 7 and 8. All right, for chapter 4, we only have section 1 to 6. And chapter 5, we have 1 to 10. But this one, actually, I just said you'd better review, follow the homeworks. So especially for this chapter 5, we have some homework problems in chapter 5. Follow those homeworks and try to understand the concept or formulas, some things from the according to the homework. You can find them from the textbook. You can also use my notes and view my video again, or even search online. For example, you have like here you have like chapter 9 is a Gaussian. It is Gaussian, right? It's a bivariate Gaussian random variables. You can even search online. You can find the material. And you can also read this textbook. Read this section. Okay, this is about how to review. And then let's go over the topics. Actually, for this part, all the things related are random variables. You can think we just have one topic, random variables. But of course, related with these random variables, we have a lot of things related with it. The first one, we have some functions. We have functions. Remember, we have CDF is f x of x. We have PMF, which is a px of x. We have PDF. It is a lowercase fx of x. Right. This is for single variables. We can also have these for multiple variables. So for a single random variable x, or for a list of random variables, x is x1 to some xn. Right? Yeah, so we have two cases. This case we call it the joint distribution. Joint, right? It's joint. Joint PDF, joint CDF, joint PMF. Right? You put a joint in front of them. We have both. All right. You can check the notes or textbook to find the definition of them. Okay, so for this function, and related with these functions, we have several kind of work we have to do. So we want to find one function from another function. For example, you know PDF, you want to find the CDF. Or reverse, you know CDF, what is PDF, right? So things like that. You know one of them from one of the function, and then you want to find another one. Right? You want to solve this kind of problem. And another thing is you want to calculate probability based on one of the function. If you know one of it, and you ask it for some probabilities of some event. Okay. And the third one, maybe you have some parameter in these functions. You need to determine the parameters. So you want to determine some parameters in these functions. Okay. In most cases, when you want to determine these, you need the rule, the probability of the whole sample space. The probability of the whole sample space is 1. Yeah. In most cases, you need this one. Depending on which kind of function. Like if it is a PMF, then your summation of all the probabilities should be 1. If you have PDF, then the integral of this fx should be 1. If it is CDF, when this x go to infinite, it should be 1. Right? So it is this one. You use this one, then try to determine some parameters. Alright. Yeah. Okay. So this is for functions. The first one. And these functions, you can think they are the fundamental for this material, because all the calculation you need this kind of thing. Then second thing, we have some average values. we have average values. We have mean of x. We have the variance of x. We also have, if we take square root of it, we have the standard deviation of x. Right. This is for single random variable. And when you have pair or more random variables, when you have a list of random variables, you will consider the values between two random variables. So you have the covariance of x and y. Right. You have r x y, or maybe the notation is r x y. Right. The correlation, covariance, correlation, and rho x y. This is a correlation coefficient. Yeah, the name is a little bit confused. This is correlation. This is a correlation. And this is a correlation coefficient. Coefficient. This one, by definition, it is covariance over just sigma. Okay, sigma x, sigma y. It's this one. Okay, so we have some average values. You should know how to calculate them based on the PDF or PMF. Okay. How to calculate. How to calculate from the PMF or PDF. Okay, we need how to calculate. Okay, then let me see the averages, and we have a related factors. We have the independent, we have the orthogonal, we have the uncorrelated. Right, we have these three different kind of relation between two random variables. This one according to the r x y equal to 0. This one according to rho x y equal to 0, or COV x y equal to 0. That's same thing, right? This one is, they are related. If this is 0, this one must be 0, right? And this one according to f x times f y equal to f x y, right? Maybe use this x, use a PDF, or maybe the PMF. Right? One of it. This is independent. So sometimes when you are calculating these numbers, maybe we also want to know the relation between two random variables. Are they orthogonal? Are they uncorrelated? Or are they independent? Okay, these are the average values. Let me see. What else do we have? Okay, I think this. Yeah, that will be all. Actually, basically, this is 1 and 2. They are all the material, all the concept and formulas do we have. Oh, we have one more thing. Some formulas right here. Some formulas. When we calculate the average values, we have some formulas, things like that. For expectation value, x plus y equal to ex plus ey. E of ax, there will be a times ex. Okay. This is for e. Then for variance, ax variance will be a squared times variance of x. And the variance of x plus y, or equal to variance of x plus variance of y plus covariance of x and y. Right. We have more formulas, I think. Okay, and of course we have this basically. Variance of x or equal to e of xy minus this is a x squared times ex squared outside, and the covariance of xy equal to e of xy, this time is xy, minus ex times ey. Do we have any more formulas? And something else like if they are independent or they are uncorrelated, this will be 0. The variance will be summation of these two, right? Yeah, some formulas. I think they will be enough. Okay. All right. Then you can think the part of topic 1 and 2, they are kind of fundamental, the kind of theories, right? And then we have some examples. But these examples, they are related with something we always use, we use a lot. So we put them together. You can think this is kind of table, right? Remember, like Fourier transform, Z transform, you have transform tables, right? Similar things. Here we have some common used random variables, and we list them. So here I say some part 3, some common used random variables. We have two types, right? We have discrete type and continuous type. For discrete type, we have Bernoulli P. Actually, this is the experiment with a coin, right? Coin. You have two possible results with the probability P and 1 minus P. And then we have binomial N and P. We have the geometric that is just a P. We have the exponential power, exponential just a P, P and lambda. Let me see. Lambda, not P, lambda. Exponential will be lambda. For discrete type, what else do we have? I had Poisson. Yeah, Poisson. This is a kind of this should be a French guy. Poisson. Poisson is also lambda or P, lambda. Yeah, things like that. And for continuous type, we have the uniform from A to B, an interval. Or we also have uniform for discrete type. I put a D here. Uniform from some K to L. They are integers. K and L are integers. So, and this A, B could be any value. Right? Uniform. Then we have the, let me see, uniform Gaussian as a normal, right? Oh, the exponential power. Exponential will be here. I should have one more. Sorry, I forgot. Yeah. Okay. Yeah, you should have one more. Something related with this, geometry, uniform. Or maybe exponential is here. Exponential is what? That is a Poisson. Yeah, we should have one more thing. One more here. I forgot. I forget which one. We have textbook. Go to the end. Okay, it's here. We have uniform, we have Gaussian, yeah, exponential. Yeah, I'm sorry. Exponential is a continuous type. Yeah, I said we have one more. Exponential. TI. Exponential lambda is here. Okay, it's continuous. This is continuous type. It's continuous type. All right. Exponential, then Gaussian, then the uniform. Right. For continuous, we have these three, and for discrete type, we have Poisson. Poisson alpha. This is alpha. Alpha. Then geometric, discrete uniform, uniform. Then binomial, then Bernoulli. Okay, we have all right. Yeah, we have these. So for discrete type, we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. And for continuous type, we have discussed these three. Actually, in the textbook, they have more, but I just go over these during our class. All right. Okay, but these for just for one single random variable, and we also have multiple random variables. So we have these for Gaussian. We have normal distribution with mu and sigma square, or normal distribution with mu and matrix sigma. This is a n-dimensional. Mu will be mu 1 to mu n, and the sigma will be a matrix with size n by n. 1n. This is n1. This is nn. This is n by n. Okay. We have these. The n-dimensional. And for the Gaussian, we have some good feature. We have the expectation value will be mu. We have the variance equal to sigma square for that one, and for the multiple case, the variance of xi will be this element, sigma ii, and the covariance of xi and xj will be this element, kind of I and j, and the expectation value in the multiple case, we have exi is mu I. Okay, we have this kind of thing. Right. This is for the some common use distributions. And what else do we have? And for the Gaussian, for x, obey normal distribution mu sigma square. We have let z equal to x minus mu over sigma. Then this one will obey a normal distribution with zero mean and unit variance. And we have table. We can use table to do some calculation of the probability for this one. Right? We call this the standard normal distribution. Normal distribution. All right. Yeah. What else? Yeah, it seems just like this. The topic here, just like this. If you just look at here, it seems not too much, but actually it contains a lot of materials. All right, so we have the functions, we have the average values, and what else do we have? Oh, this is for the functions. Actually, for the multiple case, okay, I write one more thing. The 1, 2, 3, 4. 4. We have the margin distribution. Yeah, you can say this is not just 4 parts. This is just a kind of small topic. This is marginal one. So for f(x), xy, you let one of it go xy. You want one of it go to 0 or go to infinite. That's where be x, y, x, and y go to infinite. Right? And for the density function, f(x) of x, there will be integral of f x y dy. Right? You integral on y, so after integral you only have x. And for p x of x, this is a summation of p x y of x and y, summation for all y's. Right? This is their marginal distribution. So when you have a joint, this is a joint distribution. You can find the marginal distribution for each single variable. Here you have 2 random variables, right? You have the joint distribution for both. Now, if you want to find the distribution for just one, then you can work like this. Now here I just gave the formula for x. If here's y, similar. You let x go to infinity. Again, keep y here. Right. And if here's y, then the integral will for x. Here's also, if here's y, then the summation will be for all x. Right. Things like that. The marginal one. Yeah. Alright, that will be all for this review, and if you have any question, then you can go to the office hour. Today, actually the Friday of this week, we have an actual office hour from class time. So it should be start from 3:30 until 5. So if you have any question, then go to the office hour, go to the Zoom meeting of the office hour, and then we will see in the midterm. That will be after the break. All right. Okay. See you after the break. Hope you enjoy your break. Bye bye.